So let's talk about lines, specifically horizontal and vertical lines. Those lines, it's first important to look at just the definition of a line in general. Now the equation of a line, I want you to think of it as like a set of rules. So like the way you can think about it, if I have an equation for a line that's telling me to be on a certain line, like to be on that line, I have to follow the rules that are described in the equation. So think of the equation as a set of rules to get into the club, which is the line. So for example, if you look right here at y is equal to x. So that's an equation, and it's telling us the relationship between y and x. And that's what I have just written here in words. Because y is equal to x, we can think of it as, in order to be on the line, the y value must equal the x value. So that's the rules here. So if we look at the graph, I put a few points on that line. So you can see I have the line y equals x in red. So that's that function here. So this is that line. And then I've plotted a couple points on there and some points that are not on there. So look at the point here. Sorry, -2, -2. So if I look at the point -2, -2, I can clearly see that the x value and the y value are exactly the same. So it's on the line. If I look at some other points that are on the line, 1, 1, I can clearly see that the x value and the y value are the same. 3, 3, the x value and the y value are the same. Now if we look at a point where the x value and the y value are not the same, maybe right here at 5, 6, the x value and the y value are not the same, so that's why the point is not on the line, because it doesn't follow the rules. If I wanted to add a point that wasn't here, so let's say I wanted to add the point with an x value of -5, if it was going to be on this line, the y value has to be -5, because that's what the rule says. There's like a ton of different types of rules that we can look at. So here I just have a different rule. This one says y is equal to 2x. So if I put that as a sentence, what it's telling us, which I'm going to write here in green, the y value is the same as 2 times the x value. So in other words, if I start with x and I multiply it by 2, I should get the y value. So it's just a different rule to be on this line. Your y value has to be twice the x value. So again, I have that line in red. So I put a couple points on that line. So if I look at the point 1, 2, the point 1, 2 is on the line because the y value of 2 is twice the x value of 1. Same thing with like a different point on the line. I put 3, 6 on the line. If I look at the y value of 6, it is twice as big as the x value of 3. So same thing there. We can say that the y value of 6 is equal to twice the x value. The last example that I have on the line here is that purple point, and that's -2, -4. -2, -4 is on the line. Again, we can see that because the y value of -4 is 2 times as big as the x value of -2. Now there's one point on here that I did not put on the curve. It's the point 1, 3. The point 1, 3 is not on the line. It's very close to the line, but if we look, it's not actually on the line. And the reason it's not on the line is because the y value of 3 is not twice as big as the x value of 1. So a vertical line is just a special type of line. It still follows the rules, but a quick definition of vertical line is a line that goes only up and down. So for instance, I'll just put in a few vertical lines so we can see them. Let's put them in red or something. So a vertical line just goes up and down. That's purple. But that's a vertical line because it just goes up and down. Here's another vertical line that just goes up and down as best as I can. It can be anywhere on the graph. Now it's always in the form of what x is equal to a number. So for example, like x is equal to 3, or x is equal to -6, or x is equal to 1.67. But it always has an x, and the other side is just a number. So the way that we kind of look at this then is that it's a rule. To be on the line, your x value has to be this number. So if we look at the example x equals 3, that's what we're saying. To be on the line, your x value is 3. Now, what's important to note here is that it doesn't tell us any requirements for y. Some of the other examples that we've gone through have given us a requirement for y, like it has to be twice as big as x or anything like that. So if I think about a table here, the only requirements are that my x value has to be 3. So if my x value is 3, my y value could be 0. That follows the rules. If my x value is 3, my y value could be -4. That still follows the rule. If my x value is 3, my y value could be 1, and that still follows the rule. So they all have x, right? The x value must be 3 to be on the line. So that's why all of these points have an x value of 3. So like the point, for instance, 3, 0, if I write these as points now, is on our line. 3, -4 is on our line. 3, 1 is on our line. I can do as many points as I want as long as the x value is 3. So like 3, -1 is also on our line. So if I try to sketch a quick graph of that, give myself a little room here. We're going to now if I just tried to draw a quick coordinate plane and let's plot these points. So here's my x values 1, 2, 3, y values up to 4 and down to 4. So like the first point is at 3, 0. That's right there. The next point was at 3, -4. Then we have 3, 1. And we have 3, -1. So we can see that these do form a vertical line. And again, I could have chosen any y value I wanted in between there, so I'm going to go ahead and connect the dots. So a line in the form of x equals is always a vertical line. The same rule will apply for a horizontal line, but just reminding yourself that a horizontal line only goes left to right, just like the horizon goes left to right, so there's two different horizontal lines there. Now horizontal lines are in the form y equals a number. So they're giving us a rule. So to be on this line, you have to have something true about your y value. It does not tell us any requirements about x. It just says to be on this curve, your y value needs to be whatever number. So like as an example, maybe the equation is y equals -3. So if I thought about an input-output table here, like an x and a y value, it doesn't tell me anything about x. And as we know, x is our independent variable, so I'm going to choose that. So if x was 0, to be on this line, the only thing I need to have true is the y value must equal that number. So in this equation, y must be -3 to be on the line. And again, it says nothing about y, or excuse me, it says nothing about x. So if x was 0, in order to be on the line, the y value needs to be -3. So that's on the line. If my x value was 4, to be on the line, the y value needs to be -3. That's the rule. If I plug in 5, the rule says y is -3. It doesn't tell me anything about x. If I put in -1, the rule says the y value is -3. So what I can see is no matter what my x value is, right, my x value doesn't make a difference because there is no requirement for x in this equation. The only requirement is about y. Y must be -3. So that's why over here we have all the y values are equal to -3. Now if we quick plot them, we will see that they form a horizontal line. So our y value is -1, -2, -3, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So let's just plot the first point. 0, -3 is right there. 4, -3, 5, -3, -1, -3. Now I just picked a few random x values in there. I could have picked any x value in between there, and they all would have had the same y value, so I am going to connect the dots. So I can clearly see that when the equation was in the form y equals, that made a horizontal line. Just a few quick example exercises that you'll be responsible for. We need to graph each of these functions. So for the first one, we need to graph x is equal to 3. So if we think about an input-output table, the rule here is x must be 3. But then we're reminding ourselves there is no rule for y in this equation. It just says x. So if any of the points I want to do, I know x is going to be 3. So I'm just going to put 3 of them for right now. Now every single x point just has a different y value. It doesn't matter what it is, as long as x equals 3 will be on the line. So like y value of 0, that would work. Y value of -1, that would work. Y value of +4, that would work. As long as the points that I plot have an x value of 3, I will be right. So let's go draw 1, 2, 3, 1, 2, 3, 4, 2, 3, 4. So I'm just going to plot a few of those points. So 3, 0, 3, -1, and then like 3, 4. So I can see that those do indeed form a a vertical line. So here is the line x equals 3. The next example, y equals 2. There's a rule for y, but there's no rule for x. It just says y must be -2. And there's no rule for x. So if I make a table, and if I have to start with an x value like 0, the rule says y has to be -2. If I pick a different x value for my input like -1, again the rule says the y value has to be -2. If I put in a number like 4 for x, the rule says the y value has to be -2. So if I were to go plot those on a coordinate plane, I would see my first point is at 0, -2. My second point is at -1, -2, and then 4, -2. So if I connect these points, I can clearly tell they made a horizontal line. Last one's another vertical line. This one we can do quicker. We know that here every point x is equal to -2. So if I just put my x value of -2, this point right here has an x value of -2. But if I don't want to change my x value, I can't move left and right. I can just move up and down. So like all these points here, they have the same x value. So I know that when it's an x equals equation, it's going to be a vertical line. And it's going to be a vertical line through the point where x is equal to -2. So like that one.